Hi, my name is Lucas Sanson,
I'm Justin Geyser.
and this is our project, codename Rusticular Torsion. It is a Dungeons and Dragons omnibus that helps you track initiative and imports monsters from a database. So all you have to do is clone our GitHub repository and then build it and run it with Cargo. And we're going to show you what that looks like right now. Um, So as this compiles, we essentially used Rust and then a UI framework called Slint in order to display a front end to the user that makes it more easy for the user to import and export um, all the data they want. So essentially, for a quick rundown of how this works, you basically can add monsters to the initiative tracker by typing in their name here. It'll search them in a database that Justin made, and then it'll add their AC and HP from the database, and then randomly roll an initiative roll for it. And so we have like all the monsters in D&D on here, and so you could also add players. So you could have like player one here, and you manually input like initiative if you want to, or if you have like custom monsters. And then the main functionality is that it'll sort by initiative to make it easier for dungeon masters to start combat quickly. And kind of going in line with this process of having quick combat, we also have a timer here where you could time how long somebody has to take a turn. And we can vary the amount of total time um, of how long the duration we want for the timer. Um, and then we also have this where if you want to spam horde monsters, um, for example, if you have like a horde of zombies coming after you, you could just spam this a bunch of times to summon zombies. Uh, Now you can notice here I made a typo, and so it didn't lead to the monsters being added. And so what you could do is, using this delete feature, you type in the enemies you want to delete, and then you can delete the row specifically by specifying the name as well as the initiative. Or if they have no initiative, you leave it empty. So if I want to delete, let's say skeleton with initiative of 11, I'll type in skeleton 11, and it should delete this one right here. So yeah, that's basically the functionality, and it automatically sorts initiative. So that's basically the app. And now, kind of going into the nitty gritty of how it works, we essentially just start the Slint app over here and initialize row data. And then I have this function which calls back to the UI. And essentially, what it does is it'll because Rust has ownership properties and you can't kind of share multiple things at one time, we create a clone over here of the data and create a reference copy over here. And so we initialize the database, which Justin will go into later on how he did that. And then we basically go through and create a vector which holds a bunch of the list items, which is Slint's kind of variable for holding items that get put into a table. And then we add in a current name entered by the user. And then if this name matches something that we found in the database, it'll input with their armor class and hit points from the database. And then Justin created a random initiative roller over here that uses a modifier as well as a random dice roller to add their initiative. Otherwise, it'll just take the data given in the input text boxes in Slint and push those into the table. And then it'll push that onto the table over here, and the table will be updated. Pretty similar process for the deletion. We basically get the name and initiative from the input text box over here, and then we check through and iterate through the entire row to check if it matches. And then if it does, we remove it over here, and otherwise we just print out an error. Um, so that was pretty much the majority of what I dealt with. We also have this row feature over here to update the row data, because Slint typically creates a table at compile time with a bunch of preset data cells. But using this code, we're kind of able to update that dynamically during runtime. And then over here, we also have a filter sort. I forgot to actually go over this, but let's say I want to like specify a certain player. If there's like a super long list, I could type in this filter and get basically filtered by the name. And so that also dynamically changes the table by deleting and choosing to like show certain rows. And then this just kind of runs the app. So
Yeah.
we could now go on to oh, actually, yeah. And then finally, we also have this filter sort model. This is how the sorting actually gets done. Essentially, we go through this standard list. We clone everything from the table. You know, if this filter is empty, we just filter by the first row. Um, and then otherwise, this over here sorts it by column 0. So 0 represents this column over here for initiative. And so we're able to sort by basically comparing over here to sort from ascending or descending order. Um, and this is, we also have to convert it into an integer because otherwise it would store it as a string. And we had issues with this being sorted because string sorting is kind of alphabetic rather than by numerical like scale. Um, but that's basically all of the sorting logic taken care of. And now we'll let Justin kind of talk about the monster database.
Yeah, so the monster database was built with a pre-existing text file that had all the monsters
Yep.
from D&D, and you can kind of find this resource online or just manually do it. However, the big issue was that since it was in text file and it was in a format that we weren't really comfortable with, we had to do a conversion with Python. With there, and so basically with this, just opening, reading the file, and then writing a new one, and just making sure to clean up each line. And it's important to make sure to throw out the header and then write out our own header for the file that we're going to be returning. And just overall, just making sure we clean it up. And like once we were able to clean it up, we divided it based on commas, and then we outputted a monster CSV, and that was in a much better format to read for when we go into Rust.
Yep.
And then to implement the database as well. Hold on. So this portion of the monster database was kind of just reading that CSV file in Rust because in order to make sure that we could access the data within our program. And then during the main operation of the main of main, we put this all into a hash map that had a string that was the name of the monster, and then the value was the a monster class, monster struct, which we'll get to later. But this was important as in main, this would allow us to do a check to see if the name that you type in is the same as an existing one in the database based off its key.
Yep.
And then from there, we utilize the monster value that's associated with that key. And if we go down to the monster struct, you can see that it holds the name, initiative, hit points, armor class, and then notes if you wish to add any. And then pretty much all the functions associated with our copies and just a lot of getter functions either display it with just do a print or to actually display the value depending on what you need, as well as there's some modifiers like change note, damage, and heal. And so with further implementation, one can decide, oh, I want to heal my player, so they just plug that in and use that function. However, that's not currently implemented. Uh, and then for the dice, which is another major function, it takes three parameters like the number of dice you wish to roll, the number of sides, and then a modifier. And so what's important about the modifier is that the user has to do the implementation. If they get to decide uh, if they wish to use this function, they'll have to decide on their own if they wish to use a modifier. But currently, as implemented in the app, whatever initiative you plug in is what the player gets. It doesn't roll. However, for all the monsters that are within the database, there's a simple calculation that D&D uses to find your modifier, and what we have is that it
Oh,
will roll the dice and add the modifier. So if you have, let's say, you add two goblins, they'll all have
different
most likely
modifiers.
different modifiers.
Yeah.
Sorry, initiatives.
Yeah. So if I add a
Um,
bunch of wraiths here, you can kind of see how they're all at different levels in the initiative sort. And actually, I could do a really good representation here. If I only sort by something like cultists, and then I add a bunch of cultists. So this is why the filter feature is nice. Let me add a cultist. Um, it'll basically show the initiative over here, and you see it's randomly generating, random numbers here based off the modifier.
and as well, we have a terminal print. The terminal prints out kind of what your the modifier was, and this is kind of like private for the DM, so only the DM can see.
Yeah, because typically
And
in Dungeons and Dragons, only the DM gets to see the roles that the monsters create, and so we don't want this to be accessible to the players.
yeah,
Yeah.
and as well, if anyone else would wish to work with our project, we also have file versions of the dice, the monsters, and then some other
Yeah.
features.
Um,
But
but yeah, that's basically the back end implementation. Most of the front end just is kind of static with the Slint UI. We have basically all the callback functions that we then implemented later in the Rust backend. One kind of key thing to note is the statically allocate, like what the rows data is contained in Slint normally. I found this in one of the examples in the documentation, however, where you could dynamically allocate basically the row data during runtime. And so this little callback here is taken from the documentation, but we kind of made some modifications to it in the backend. So it basically creates a callback over to the back end where it's like an input and output so that can communicate back and forth. And that's basically what allows us to push these items into the table. And also, it allows us to dynamically sort the list because we're essentially deleting and then adding rows every time we use like a filter. And then we also basically, have these line edit inputs that also communicate with a global variable, such as like the initiative or whatever. This is pretty standard stuff for like front end development, and there's not much logic behind it. It's mainly just code to kind of display on the UI. So it's just calling back functions whenever we receive like an input over here. But otherwise, this kind of doesn't do much of the lifting. Kind of like the only kind of programming we do in here to note is that this timer over here actually runs like logarithmically. So you can see over here, the total time is increasing very slowly, but then over here, it increases very quickly. And so we did this to make it easier to select large value times while still maintaining control over like precise times, like smaller values, if you want to do something only like 60, 30 seconds. So it kind of opens up both those options. But yeah, this is basically our implementation, and we are pretty happy with how it runs. It basically does everything you need to have it do while playing the game.
yeah,
And is there anything else you want to add, Justin?
I mean, I think we hit pretty much all of our bases, and it was a fun process. As I know, we struggled a little bit with getting the UI to work with us first working in the terminal, but then in the end, we made it. We made the UI able to be interactive, and so overall, it's a good project to really like show the interaction between front and back end. Um, and overall, it's a product I would say we're both happy with, and we know that we'll both be using in the future.
Yep, absolutely. Well, thank you for looking at our project and give it a try for yourself if you're into Dungeons and Dragons.